This is a suitcase sensor for SHT10, which is a humidity and a temperature sensor. And it all fits inside my Raspberry case, which is kind of nice. Here's the sensor. Heating it up. There it goes. Bigger jumps. Female end of an RJ45 wire to B, which seems to be the most popular network cable. That way I can grab any one of my network cables and put it in between here. Arduino Mega over here, which houses the screen that you actually see over here. For the actual sensor devices, right now it's just the SHT, but now I can expand it to more sensor devices. And there's a serial connection between the TFT screen. Arduino Nano. I've hooked it up so I can just plug it into the side of the box here. Oh, that's what I wanted to show you. All right, I know you can buy these for around 30 or 40 bucks, but this one's mine. This is a suitcase sensor for SHT10, which is a humidity and temperature sensor. And it all fits inside my Raspberry case, which is kind of nice. It's built with a Arduino Mega over here. Arduino Mega over here, which houses the screen that you actually see over here. And for the actual sensor devices, right now it's just the SHT, but now I can expand it to more sensor devices. And there's a serial connection between the TFT screen, which is going to display the data and the outputs, which I programmed to do that, and it's going to get it through this serial communication from this Arduino Nano. This Arduino Nano is getting 5-volt power off of this one, and the ground is connected. That was important. And the SHT device is a 4-part connector. So it has a data cable, the green one. This is supposed to be yellow, but I patched in a different wire because it's to a network cable. So the green is the data, yellow's the clock. This is the voltage, and there's a ground wire in there as well. And here's the actual measurement device. So I've hooked it up so I can just plug it into the side of the box here. I can take it out, plug it into the box, and drop the sensor in wherever I need it. There's the actual sensor, so it's a humidity and temperature sensor there. So let me put this baby together, and you can see how it works. Okay, so this cable can be unfastened and rolled out, and the network cable, I just used like a normal Cat 5 network cable I had hanging around, and I bought some connectors so I could create this female RJ45 connector for typical network stuff. Over here, regarding power, so I've used a cheap, I believe it's a 9-volt or 12-volt adapter to supply power to this unit just while I'm here on the desk. But I've got some battery ones that connect to 9-volt batteries and have the same male end, so I can just use a square 9-volt battery and instead, so I can actually be mobile, because we're going to be using this for testing soil temperatures at different depths on my brother's property. So it's registered in Celsius, and there you get the humidity and this is from the SHT sensor. So let me see here. Not there. Where have we got it? Come on, sensor, you're wound up. Oh, there we are. Okay. So I can hold my hand on it, and the Celsius should go up pretty quick. Oh, it's got to get through this metal part. part. The humidity's going up fast. There we go. The temperature's going up now to 65% humidity on my hands, and not very warm hands apparently. Just 23 Celsius. Well, if I blow on it, oof, the humidity goes way up. As to how I got this working, the programming of the Arduinos is a separate thing. I don't know if anyone's interested in that code. It's not even very good quality code. I just kind of got it working was the most important part. Programming for these TFT displays, there's lots of people that have how to do that. So one of the challenges you'll find with an Arduino Mega is that it actually, this device takes up the whole Arduino Mega, and I needed 5-volt power to go over there. Otherwise, I'd need to get another battery to supply the Nano. Oh, and the Nano, maximum voltage it can take, I believe, is 6 volts. So I can't just plug a 9-volt battery into it. So I'd also have to step down the power anyway. So I had to get the power from this Arduino to support the Nano that I built there. So let's have a look at that Nano board. All right. Now some of this is pretty darn ugly, I know. These network cables are still dangling around here. It doesn't look real professional. Okay, so you can see an Arduino Nano here, and I put that in with, you know, 2 of these female pins that go through a circuit board, and I set another set of those so I could plug things into it directly to connect to the different pins. It's kind of like building your own, what do they call that? Yeah, never mind what they call it. But you can see, I don't know if you can see that right there, where I was soldering to go across to get from one to the other. Oh, that is such a nightmare. I don't have that skill. It's very, very difficult for me. You know, the lead or the solder keeps following the iron along, and then it beads back up again, and then you get too much and it connects to the one beside it. So that was a real nightmare. Took a lot of learning for me to get that. Oh, I just cut my power on the Arduino here. Sorry. There we go. Yeah, I've got kind of shaky pin system there. I'm trying to think of something good and solid to do for that. Well, it's only permanent for this piece of wire over here. It's kind of permanent for the circuit board, but that's what all this circuit board is going to get used for, is this suitcase sensor. What else about this? Okay, a little bit tangly cable here, but these yellow and orange ones you can see going over to the Arduino Mega. Oh, that's what I wanted to show you. Sorry, before that. So remember how I said there was a power problem? I needed 5 volt, and this TFT screen takes all of the power, or all of the pin positions. So you can't get 5-volt power off it because the screen itself needs it. Now you can go and buy a $30 shield. That's what they're called. That's the word I was going for before, shield. But what I did instead is cheated. So these yellow things are really just a plastic surround. So you can pull this whole roll of yellow collars on this metal up. So what I did was I pulled this row of yellow collars up, and then I cut out the third one, and I pushed the 2 back down on there, I pushed the 3 back down on there, and then I soldered in my power wire. So I kept it below the yellow collars, and that way I get my 5 volts, and the TFT screen gets its 5 volts. And all I did was, you know, modify my TFT. I mean, I wouldn't even believe it if they told me they had a warranty. So that's not a real concern, and it worked. So, and then there were a couple people out there that are like frustrated because a TFT takes an entire Arduino. It's like, if you can't hook any devices up to a TFT, what's the point of it? Which I totally get. And, well, It ended up looking decently professional. Oh, I probably have disconnected something. Let's make sure I've got this in the right pins. Come on now. I know. You are telling me I shouldn't be disconnecting it and reconnecting it while it's live, but if you're going to be my device, you got to be a little bit tough. There we go. Yay. Put up with the Dutchman. Wooden shoes, wooden head, wouldn't listen. Brute force and ignorance and all kinds of terrible, terrible things that I do. Okay. What was the other thing? Oh yeah, so hooking this up, that was how I got the 5-volt power. I can get the ground right over here, so that was no problem. The 5-volt, I had to do that funny thing. I'm planning to hook up the 9-volt battery and just install a little square battery here to power, that'll just power this from there. And the Arduino Mega, and I believe the Arduino Uno as well, can take up to 20 volts, I think, input and regulate it to the voltage that they actually need. Another interesting tidbit. Without that red wire taking 5-volt from the 5-volt output of this Arduino Mega on this side and going over and supplying voltage into the Arduino Nano, it was working anyways, and it was freaking me out. I'm like, if I pulled the ground out, it would stop working. But I put the ground in, it would work. The Arduino Nano still had, its light was still on. It was still giving me measurements, and I didn't understand that. But apparently, I found out from going through some forums, these data cables will actually pass power into the chip. But apparently it's not a good thing to do because they're not really supposed to take those kind of currents. So whatever draw that this measuring device could be larger than these chips should take. But it didn't seem to affect the readings or anything. I don't know everything about electricity. I wish I had Big Clive to tell me what's going on with that. But watching one of his videos, maybe something like that will come up. But I don't know, or maybe I'll send this to Big Clive and maybe he can analyze my terrible job at wiring this. No, this is not production stuff. This is just for my use, so I am going to fix this. I got to do something different, but I don't know what kind of connectors can go nicely into pins really firmly and be horizontal and more flexible. Maybe I should just say that this network cable that I built here is committed to this device, and that's it. Here's the sensor, heating it up. Takes a little while to get through that cold metal surrounding, but it's going up. Moisture reading will go up pretty high too. There it goes, bigger jumps. I like to write the Arduino code so it shows a little graph underneath over changes, but I don't know how much change is important usually when you're measuring something like this. Better to have data logging. So this is the actual SHT10 device, and I've connected it to a female end of an RJ45. Please ignore this. This is a solder case just to make it stronger. Female end of an RJ45 wired to B, which seems to be the most popular network cable. That way I can grab any one of my network cables and put it in between here. And goes into here, which is wired 4 wires into the Arduino. It's getting its voltage from the Arduino. It's getting its ground from the Arduino, the clock cable, and the data cable. Sorry, there they are. Now from this cable that's coming in, I hardwired it. It was just getting ridiculous, these pins that could keep unplugging and everything, so I just soldered all the pins into their correct locations. But now this Arduino Nano can be removed but this wire is soldered in now. So I picked 4 network cable colors to go through in here, and I had to make sure I had the same 4 when I wired this. That was the only thing that was important. And to stick to the same standard, you can see there's an A and a B standard there. So choose to stick to the same standard when you wire it over here, and everything's good to go. And here's a quick overview of the entire final assembly. You can see where I've gotten a battery working instead of the full power supply, and it all came together in a nice neat package. Thanks for watching.